Hello, everybody. Good afternoon. Thanks for staying for the presentation. Nice you're not running away. It's the last one. I am honored to be the one closing the day. What I'm going to talk about today is a service. It's a service for researchers. Main focus was the researchers when we were building it. And this is the Danish Biobank register, as it says on my slide, a national initiative which enables activation of the pre-existing biomedical samples, which are there all around Denmark in different biobanks. So this is what I'm going to talk about. But before I move on, there are two things. One thing is that I'm going to spend 10-15 seconds to tell you about myself before I move on. The second thing, very important, during this presentation, this is the first time it will be a new feature publicly announced in the register. It's available just for a couple of weeks. It wasn't announced, and I'm going to talk about it today. This is a new thing. So some of you who know Biobank Register, I believe there are some who know, there is something coming in which we didn't have before. I think it's exciting. So about myself, as I promised very briefly, my background, I have a master engineer in telecommunications, computer science, and then PhD from DTU Compute, Technical University of Denmark, in biomedical informatics, more precisely neuroinformatics and semantic text mining. And then I started at the State and Serum Institute with challenging task to actually start building and designing the Danish Biobank register at the same time when the biobank building was about to be built and the whole biobank to be established. It took some years to actually move on with everything, with physical biobank, also with the system. It was available first time in 2012, but then we were moving on and then trying to find out other biobanks which can jump on the platform. In the beginning, we started just with few collections from State and Serum Institute, and then we moved on. So then in 2017, I progressed to actually take over our small IT unit in the biobank. And then finally in 2020, when the pandemic started, since our direct involvement in the integration of the Test Center Denmark laboratory, since we had this competence in the team, we actually grown to become an IT section, which I'm leading and proud to be. All right, very briefly, Danish National Biobank, as I noticed, you didn't get that introduction, at least not today. So I was thinking just very briefly to tell you what is the Danish National Biobank. You can see here on the picture, this is this building. This is the only one which is so new around all these old buildings at State and Serum Institute. And what the Danish Biobank is actually one of the most technologically modern biobanks in the world, which actually includes that we have diverse automated storage systems, -20, -80, robotic freezers, which just do everything. We don't need to come inside. It brings the samples when needed. It also has a diverse long list of different type of manual storage, -20 walk-in freezers, -80 manual up to the nitrogen tanks. In total, the storage of the biobank is estimated to 50 million, and we are actually close to that moment to say that we almost filled up. So we actually starting discussing what to do to expand the storage space. But apart from the storage in the biobank, what the biobank offers is also the high throughput automation, liquid handlers, robotics, so we can actually aliquot the tubes which are coming, the fresh samples, using the robots. Everything fully automated with the LIMS system, as well as high throughput service, not only in the biobank, but the whole State and Serum Institute, from metabolomics, genotyping, sequencing, different type of machinery here available for the researchers, so they can actually get it done here. Very briefly about our IT team. So as I mentioned before, we are responsible mainly for running these two systems for the biobank, as well as the test center Denmark IT system we built in-house. On top of it, we help researchers. We actually involved in every single research project which is coming to the biobank, generating different data extractions, pick lists to find the proper samples. But also we actually build and run national systems. And one of these systems is the one I'm talking about, the Denis Biobank register. But I also allowed myself to mention the other one, which could become maybe in the future also part of the register. It's a very fascinating Horizon 2020 project we have implementing. This is an ESAM project, which actually is gathering consents from Danish citizens in order to collect, the shopping habits, like the digital receipts from the groceries, from all those supermarkets which are in the network. And then when this data collected, it could be used also to enrich the data about the samples, knowing what people are buying, find out what it can cost, what we eat, what we buy. So this could also be a register in the future, maybe, which can be part also of the Biobank register. But let's move on to the essence of the talk. Danish Biobank register. As you can see, this is a system which actually integrates different biobanks, metadata about the samples in different biobanks. We don't get the physical samples, just the data, with different data in the national registries. And here comes this little star. I'm jumping into that right away because you already see it anyways. We not only use the diagnosis codes as we did before, and not only pathology codes, SNOMED codes to actually link and reach the samples, but actually from now, it's also available to actually use the laboratory results analysis codes, NPU codes, to also filter on samples. So I'm going to show you that a bit later. The Biobank register is accessed via this link or this QR code. And to say more about the system briefly, it allows advanced filtering of samples based on diagnosis, based on different biobanks they are collected in, different sample types, different dates, and as I mentioned, NPU codes for analysis results. It provides also this dynamic sample classification. Thanks to this data I just showed you here, it can also split the samples into those which were taken before the first diagnosis, at the diagnosis time, and after the diagnosis time. So the researchers can actually pick samples and date different groups of samples to actually analyze both samples taken before and after the given diagnosis was given to a person. Finally, the output. This is very important. This is not a system where you can access individual level data. You cannot actually send any application to the system to get access to the data. That's not allowed. That's not the purpose of this system. What you can get is very quickly on a website, freely available way of searching and getting aggregated results. Where can I find how many samples which I actually search for? Briefly about the participating biobanks. As you can see, different biobanks located in different places in Denmark, starting with the Danish National Biobank, both old samples from the State and Serum Institute, from the diagnostics, very big collection of neonatal screening filter paper samples from small newborn kids, as well as the recently acquired throat swab samples from the Test Center Denmark. Mostly positive ones only. There are also some collection of the negative samples as well. And not to forget the Danish National Birth Cohort, a study on a pregnant woman collection of samples. Apart from our biobank, we have regional biobanks like the Danish Copenhagen Hospital Biobank, which was the next one just after the launch joined the Biobank register. Region Zealand Biobank. We have also different smaller biobanks, research biobanks like DD2 Diabetes Type 2 Biobank, Open Biobank, Asthma in Childhood Biobank, COPSAC, Twin Registry Biobank, from Modens, Danish Cancer Society Biobank, Blood Donor Study Biobank, and then Danish Cancer Biobank with the cancer samples from cancer patients. And the last but not least, also a very huge 70 million collection of the tissue sample, Pathobank Diagnostic Biobank, which, as you can see, these blue dots, even the headquarters is here around the Copenhagen area. Actually, the samples are actually saved all over Denmark. In total, the current status in the system, we have data about 27.8 million samples, which actually results in 6 million donors. So this is what is available, not directly individual level, but aggregated. You can search through these data sets. I already said about it, but just very briefly to recap, these registries are used in the register, civil registration system, to know the PIN number, which is the key to connect to all the other registries, date of birth and country of birth of the person. We do not collect in the system any more data about from civil registration system, just date of birth and country of birth, even not place of birth. And then different registries, inpatient register, national patient register, LPR, Ländspatient Register, with the diagnostic codes, ICD-8, 10, pathology register with STOMAT codes, and the lab register I told you about. Here I have to mention, now we started only with the pilot, so this is our partner in this COPLAB, Copenhagen Primary Care Laboratory database, which collected, I wrote 200 million plus. I think this is a little bit too much. It's slightly less than that. It's a mistake, but these are lab results collected around Copenhagen area between 2000 and 2015. And they are in the system. You can use them. You can log into the, not log in, open the website and search. I made a demo of the search, so I hope it works. To access the system, you need to go to the Biobank website and click Danish Biobank Register. Then you can read about the system, basically about what I just told you, maybe some more. There are links to all the participating biobanks and the registries, so you can read about it as well as see the video, how to use the system. And then when you click on the link below the picture, you go to the system. Here on the first part, like first phase of the system, you can choose different, you can define your cohort. So let's say you can choose that you're only interested in people, only in women, men samples, or both. You can choose which country of birth are interesting, or select the ranges of year of birth and age at sample taken. This one, more exciting, more specific. You can specify which disease you want to study and find samples for. You can type diabetes and find the ICD-10 codes and choose the right one, or just type the ICD code and select all parent-children codes for diabetes, as I did here. But in Denmark, before 1996, we used the ICD-8 coding system in the healthcare. That means that if you want to broaden your search, you need to use also ICD-8 codes. So then you get all these older cases. And then, of course, you need to research and find out what are the codes for diabetes. I was actually playing around 250 diabetes type 2, 249 is diabetes type 1. You will just see it. And then when you find the right ones, you need to select them and add as a search criteria in the system, as I do now. There are also two other options. You can add secondary disease. So you could say samples from people who have a diabetes type 2 diagnosis and some, let's say, other disease. Or you can exclude some diagnoses. So you can say only diabetes patients which never had any cancer, for example. I don't know if it makes any sense, but just as an example. When the diagnoses are defined, you can jump to the sample tab, and here see all the participating biobanks and decide where do you want to search for. I mean, you don't need to choose all, but this is selected by default. You can select also the sample types, blood, tissue, or other types. When this is defined, then we can jump to the new feature, which is actually lab data. And here I've chosen to choose LDL cholesterol as an example. So you can write this type of test. You can write cholesterol, or you can write the specific name or the NPU code as well, and then select it. I selected. You will see it in a second. LDL, and then I will choose only these samples from patients who had at any time in their life elevated cholesterol only. You will just see it in a second. So just added LDL, and now I will deselect normal range and low cholesterol just to keep the high one. You can also define that you only want to find samples which had elevated cholesterol around the sample taken time. I didn't do that here, but you can do that in the interface. The last step is to define how do you want to see the results. This is aggregated type of output you get. So you need to define how do we aggregate. What I chose is to see how many samples per biobank per sample type we can find and how many donors. Finally, the very unique feature, which I already mentioned about, is that you can also specify that you want to split these samples into samples taken before the first diagnosis of diabetes, at the diagnosis, and after. To do that, you define the window. What does it mean at diagnosis? I said 14 days before, 1 year after. And when defined, the email has to be given. You can label your search with some name. I'm writing diabetes type 2 plus high LDL, and then I submit. When this is done, the system sends an email with results normally after some seconds, minutes, depending on the traffic on the server. So when the email arrives, it looks like that. You get some summary. What did you search for? You get your search criteria specified. Again, just as a reminder, what did I search for? All the diagnostic codes, all the sample types selected, biobanks, and then we come into the output tables. Here, as you can see, unfortunately, maybe the internet speed is not so high, so you cannot see it in this high quality as it is. But you can see different biobanks in different columns and numbers, and we can see that there are, for example, 50,000 plasma samples for the diabetes patients. This is without the filtering on lab data yet. The first tables are before lab data. In the second table, you can see exactly the same info, but just on a donor level, how many donors behind those samples. And then finally, the third table shows this division classification on samples taken before, at, and after the diagnosis. It's coming now. You can see every single sample type has 3 different rows showing if it's how many samples we have, how many donors behind the samples we have, which have samples taken before, at, and after diagnosis. For example, here 4,000 before, 1,000, 2,000 at, and then at 20,000 after at the diagnosis of diabetes. When I scroll down more, there are coming 3 extra tables filtered by this specific LDL code, elevated LDL. It's coming just in a sec. It's marked with blue color, so you can see there is again a reminder that this is LDL, the type of analysis we chose, and we can see that it's like much less because we filtered specifically on that laboratory analysis code. But we believe this is something what the researchers or you would like to use to actually find precisely those samples which will be very good for your study, hypothetical study you want to run. So when looking through these tables, a researcher, one of you, finds out this is enough, then you can contact individual biobanks from the biobank register and then discuss how can I get samples. But this is not done through the system. How does this system help? I was thinking it is oriented around researcher, and researchers have ideas. That's great. That's how it should be. Before the biobank register, it required that when an idea was there and it was a concrete idea, the researcher had to actually write the applications to get access to these sensitive data sets, to gather actually the list of cases, and then ask biobanks separately, can I find relevant samples in your biobank? It took weeks, months. And of course, if the answer was yes, no problem, then they could move on and get the samples delivered. The problem is that the answer was no, then there was a lot of waste of time and money because it also costs something to apply. Now with the biobank register, you can make a search in seconds, minutes, you can get the answer. If it's a yes, you can move on with the whole process of applying. If it's a no, you just search again. Maybe you can actually change your criteria, you can make it broader, and then find out if you can find some nice setup for your studies and can move on right away. To summarize, jump a little bit too quick. I actually decided to draw this lifetime line, like life course line, from birth to death, with a little baby in the beginning, and then the system. What it does, actually, among all those samples in Denmark, behind the scenes, it tracks, not tracks, but registers in different registries. Where are the samples? What are the diagnoses we get in different time points? What are the medical procedures? This is also part of the register. You can also search on medical procedures with ICD-8 codes and also split the samples based on that. For example, diabetes diagnosis, pneumonia diagnosis, USG scan, abdomen procedure. But then also there are different lab results. All these taken together can allow the system to tell you, okay, which samples were taken at the diagnosis of diabetes, which were taken before and after. This is just to recap what I just showed you. So just to wrap up, Biobank Register is a tool for researchers. It shows you nationwide overview, very quick overview of available samples which can be used for research, and allows this filtering based on registry data without actually applying to access it, because you don't get this data. You just use the criteria to actually use the register data. So no application needed to use the system. PIN number behind the scenes is used as a key to link between different registries, very important thing. Without that, it wouldn't be possible. And I kind of steal one-stop shop from you, Eva. But it is in a way one-stop shop overview of existing biobanks. You can come one place and find all the biobanks. That's the point, that's the aim, and that's what we want to move on, find more biobanks in Denmark which are not in the system. If you know any, please let us know. Future work, very briefly, we would like to include the whole laboratory register, not only the pilot collection, which I just showed you, which actually includes over 1 billion lab results, and it's collecting every day. We'd like to include the Danish National Microbiology Database, so we could also filter on, maybe, if possible, if given permission, COVID-19 line list to also show the samples which are coming from people being tested positive, negative, and so on. Include metadata on available data sets. So all these studies which were run on our samples and also samples from other biobanks, they actually, after the project is finished, as you know better than me, it generates a lot of data sets, but we do not have any place where we can collect all these data sets back. We are entitled to gather them back from the researchers, but we have no space to actually put them on. So this is our aim and hope, that we can get a national data bank on some supercomputer where we can provide this data instead of samples to the researchers in the future. They can get private cloud environment without a way of actually copying the data out of the system, but actually to do studies on the data as well. So that would be it. And to acknowledge first Steve, who took over from me at some point to actually implement further the system, but also the whole IT team. We are actually having great brainstorm every week, every day, and without the team also wouldn't be possible. All the colleagues from the Biobank, I mean, without the lab, without the legal help from coordinating center, also it wouldn't fly so well as it does. Colleagues from DIAS at SSI, who actually stand behind this microbiology database and epidemiology surveillance, as well as colleagues from COPLAB. At the end, last not least, Novo Nordisk's foundation, which actually initially and still continues funding Biobank register project and its development. Thank you.